Okay, so our next speaker is Merryl Ford, and she's a digital transformation specialist at the CSIR in the Center for Robotics and Future Production. I'd like to call her on the stage. Let's give her a warm welcome. So Merryl has her passion lying in application of advanced and innovative information and communication technologies that will lead to socio-economic development in South Africa and Africa, which basically touches a little bit on what the question was alluding to earlier. But based on what the previous speaker has presented on, you would have seen that we need to make decisions based on information, and there was a single point there which talked about a single version of the truth. And for me, this is where Merryl's contribution comes in terms of, if we get this bit of information, how can we trust it? And that's basically where her talk is going to be focusing. She'll be presenting today on the potential of blockchain in the manufacturing industry. And just a special note that after writing a white paper for the CSIR on blockchain and its potential in 2018, she developed a blockchain strategy for the country, focusing on research and innovation. And the result of this was an entity called SANBA, or the South African National Blockchain Alliance, which was launched in April 2020. I think the term blockchain specialist may be an understatement for Merryl. But yes, welcome, and let's get going.
Thanks very much, Anil. So, yeah, I just wanted to say that, where blockchain, rather than a single version of the truth, with blockchain, you have multiple versions of the same truth. And basically, that's the crux of blockchain. Okay, so this is basically what I'm going to be talking about today. I'm not going to spend a lot of time on this slide. Come on. So I thought it was important to kind of talk about the 4R versus Industry 4.0, because sometimes those two terms are kind of used interchangeably. And they're actually not the same thing. So for me, the 4R is this kind of combination of various technologies. We're looking at all of these new emerging technologies, but at the same time, the 4R isn't only about technology. It's about new opportunities, new business models that all of a sudden become available because that technology now exists. It's about understanding issues around governance. If you're a policymaker and technology is changing so often, how do you actually handle that in terms of regulations? We're seeing a lot of kind of work happening at the moment in the blockchain cryptocurrency environment, where South Africa is looking at, how do we actually manage this whole new version? Is this a digital asset, or is it digital money? And how do we handle that as a country? And there's a lot of work happening, and I think one of my colleagues will talk a lot about that a bit later on. Of course, the Fourth Industrial Revolution also changes the way society works and can work and should work. I think we all experienced a bit of that as part of, what happened during COVID. All of a sudden, we were having Zoom and Teams meetings. We were working from home. Who would have thought that change would have happened so quickly over a period probably of months? This is literally the first time I've stood in a conference area, an auditorium with so many people in 2 years. It's mind-boggling. And then, of course, what comes with that is issues around inclusion, e-readiness or readiness to use technology, and then new types of work. There are fundamental changes that are happening in our society, and people need the skills to be able to do this new kind of work. The environment obviously should always be taken into account. You should look at the effect of new technologies on the environment. So that, to me, that's the 4R. And then as part of the 4R, you've got some basic technologies that have to be available. You need to have digital IDs. You need to be sure that the entity or the person or the organization that you're talking with in this digital world actually does exist and is real. and various other things like cybersecurity you'll see becoming much more important in the future. So basically, Industry 4.0 is basically industry's application of 4R technologies within an industrial environment and context. And all of those things around technology, business, governance, society, and the environment apply to Industry 4.0 as well. I was just saying to Chanel, it's the first time I'm actually not saying what is blockchain in a presentation. I'm hoping that everyone has some idea of what blockchain is. But I thought it'd be interesting to share how I think blockchain fits in this kind of 4R technology stack. So for me, blockchain is basically the trust foundation for all of the other technologies that are out there. It provides information, it provides trust, it ensures that data that is being collected actually cannot be changed, that all the other technologies that actually work on top of blockchain, for example, if you're looking at Internet of Things, if you've got a supply chain kind of use case, that the data that's collected through those Internet of Things devices can be trusted. And that the actual, when you start going higher up the chain and you start doing data analytics, that actually the analytics you're doing is based on the correct data. And that is critical in today's age. I mean, we've all seen what's happened with fake news, et cetera, People don't know what to trust anymore. They don't know what data to trust. They don't know, trust is a major issue that's emerging in this kind of new world of the 4RR. Okay, just some quick, I will quickly just go through some of the benefits and the value proposition of blockchain. If you're using a public blockchain, you have transparency because you can actually see everything that's been added to the blockchain, both by yourselves and by others. You have reduced costs. You don't have these kind of middlemen or middlewomen anymore. You have quite a lot of disintermediation. So your trust has to move from a central focus or a central entity, whether that's an organization, whether it's a person. You need to actually start trusting the network itself, the algorithms that run on it, etc. And that's quite a big ask still. Issues around fraud minimization. If you can trust the data and you can track where a product came from, then it becomes impossible to produce a fraudulent product. Some of the current issues in the global manufacturing industry. So I'm not going to go into too much detail because Gerard spoke about these in quite a lot of detail, and he very nicely contextualized it to South Africa as well. So I'm kind of looking at it from a global perspective. Supply chain disruption, major after COVID, both in terms of skills and in terms of goods. Lack of traceability. I think there were lots of issues with kind of fraudulent goods that were, medical goods, for example, that had to be imported during COVID. So lack of traceability is a huge problem at the moment. We're seeing counterfeit products emerging like you can't believe. Lack of accessibility and visibility. Sometimes, for example, supply chains are very unequal. Only some people can see all of the information, yet you are part of that supply chain. So a lot of work needs to be done in terms of making both a supply chain accessible, so everyone has the same access to that information, whether you're a small supplier or a large supplier, and where you can actually look at what's happening. Why haven't your goods arrived yet? And blockchain is really good at that kind of tracking use case. And then also lack of intellectual property protection. Major problem in the world. That goes kind of hand in hand with counterfeits as well. And then struggles in reducing costs. Major problem around the world. You know, I'm not going to go into too much detail over there. So if you look at, I mean, the biggest blockchain use case in manufacturing at the moment, and the one with the most potential, is definitely with regard to supply chain management. And we're starting to see some really innovative products emerging from the big players, the IBMs, etc. of this world. We're starting to see blockchain platforms emerging, sometimes kind of still accessible because these are emerging technologies and the resources you need to actually develop these solutions are quite expensive. So, you know, I think there's potential in creating, for example, a supply chain management solution that looks at South Africa's specific problems as well. We're seeing the World Economic Forum doing a lot of stuff around blockchain as well. They've created a toolkit called, and have a look at it. You just Google it. It's an excellent piece of work. It tells you how to go about from when you've got kind of an idea that you would like to use blockchain within your supply chain, all the way through to how you actually start to develop the blockchain solution. And this is just an example of a use case in manufacturing. I mean, blockchain, if you look at kind of the green blocks, that's kind of at a very, very high level your supply chain process. If you look at the bottom, you'll see it's running on top of a blockchain platform, and there are various kinds of data that can be collected, whether it's real-time tracking data, so you can actually, as soon as you kind of move from one entity to another along the supply chain, you can capture the GPS coordinates, for example. So it means you can track it and you can trust that tracking data. You can also kind of capture things like audits and certifications. So if, for example, you're in a food safety environment, you can actually ensure that and capture that certification process via the blockchain as well. And then provenance as well. So where did something come from? What was, you know, how was it produced? Was it ethically produced? What are there issues around sustainability for this product? How do they treat their laborers, et cetera, et cetera? You can capture all of those things on the blockchain. So, and we're starting, as I said, we're starting to see the big guys coming in and developing some really good blockchain platforms. IBM is one of them. And there are multiple other kind of large-scale initiatives that are looking, for example, at external kind of trade finance use cases for blockchain. Because trade finance is one of the most difficult, I understand, things that you can do because of all the paperwork that goes with it. If you can digitize all of those processes and ensure that the money flows between the entities, then you've solved a huge problem in the world today. Yeah, so next one. I wanted to show kind of a big use case. This is being used at the moment by De Beers. And basically what they do is they have digital tracking of diamonds from mine to retail. So it's not a public blockchain. They use their own kind of private permission blockchain. But basically every single stakeholder forms part of the blockchain ecosystem. And as the diamond moves through different processes, each stakeholder captures the data on the diamond. And basically, it captures the attributes, it captures everything about the diamond, so that by the time it reaches the jeweler and gets sold to let's say, a normal consumer, you've got a full history of what happened to that diamond. And they did this because of issues around blood diamonds, for example, and also because it made their whole process a lot more efficient, and they could get better data out of the whole environment as well. So it enables real-time updates. There's greater transparency between all the players, and it's auditable because you cannot remove data. Once you've added data to the blockchain, you cannot remove it. Blockchain is basically a write-only environment, and you have duplicates of that blockchain on thousands of nodes around the world. So if you want to remove anything, you have to remove it on every single node at the same time, which currently technology cannot do. I'm not saying it can't happen in the future. Some more use cases. Additive manufacturing, perfect use case for blockchain as well. The protection of IP, which becomes important once you actually have additive manufacturing. You don't necessarily want everyone to copy your design that you spend, years improving and working on. It supports digital twin technology. It enables machine-controlled maintenance. I mean, where the machine can tell you that, hey, actually, it's about time that I was maintained because the last time I was maintained was on a particular date. And then obviously the counterfeit protection as well. So the best way to kind of show all of these things is kind of a use case. And I've looked at an on-demand spare parts in asset-heavy organizations use case. So I'm looking at additive manufacturing in a mining environment where if a machine breaks down, the mine or the OEM is able to kind of on-site or close to site quickly manufacture using a 3D printer. And it's in the mining industry. So I'm going to, let's see if I can use the... I'm going to turn away slowly just so that I can see where I'm pointing. So if you imagine a scenario, you've got a part, let's say it's a coupling hub, has broken down in a mine. What happens is that the mine operations manager would then log in to a parts virtual warehouse and order a spare part using that. As soon as he starts using the spare parts warehouse, all of that information is encoded onto the blockchain. You'll see the green there is the unique hash or ID of the transaction that's happening. And then let's say there are 3D printing facilities available. Let's say mobile 3D printing facilities available close by, or there are multiple that are busy helping to serve this mine. They would get a notification to say, hey, there's a problem, something needs to be replaced. Then the mine operation manager is informed that the order has been accepted, because behind the scenes, if you imagine the kind of Uber solution for this, behind the scenes, the system then finds the closest 3D printing manufacturer. They might look at whether they focus on particular types of things, but they do a matchmaking then. So they say they select the most appropriate 3D printing facility. All of this gets captured on the blockchain, you'll see there. So let's say they accept the job. You let the mine know, okay, we've got I think it was a 4-hour ETA turnaround. You can track the process actually as it happens. The 3D printing facility, we would assume, has some kind of a license agreement with the OEM. They log into the virtual parts warehouse. They access the IP system. That's logged as well. And they're able to kind of download everything that you need to do to print those parts. The parts start printing, the 3D file is sent. As it starts printing, you log that and record that. There's some post-processing that happens that checks the QA. and that gets registered. You might want to have the part marked with various information. Potentially, you could actually use the actual hash of that part. There's a QA process that you capture as well. Because remember, you want to be able to use this data to show that this conforms and this is, it's safe to use this pot in the mine. So there's various legal requirements for doing this kind of thing. So you have a QA process, and then I just threw this in because I thought it would be fun. Then what you can do as well is you can generate an NFT certificate. So forget about NFTs in terms of all of these kind of pictures that you pay thousands of dollars for. An NFT, all an NFT is a digital receipt for something that's either digital or physical. Okay, so you have a digital receipt that proves ownership. So you generate an NFT certificate. It gets printed and you use it to label the part, for example. Let's say it's small enough to be delivered by a drone. The drone then flies to the mine, delivers it 2 hours later, delivers it to the mine. Now, if you can imagine the same use case in today's world, okay? It could take months to get the spare part, especially taking into account the problems that are being had at the moment with supply chains around the world. You cannot get hold of some of this equipment. But if you could print it on site or close to site, you're already like 3 months ahead of where you would have been if you had to wait. So this is it kind of shows different use cases. So, I mean, additive manufacturing, there's huge use cases for blockchain there.
Sorry, Merryl, can we wrap up just now?
Okay. And yeah, fraudulent parts. I mean, you can't replicate all of that information that you captured. Digital twin and machine-controlled maintenance, because you know exactly when that new part was installed in that machine. Okay, so there are challenges, obviously, with any new technology, and this is very much still an emerging technology. It's a team sport. You can't do blockchain on your own. If you want to do it in a supply chain, every member of your supply chain should be on board. It's emerging. There's a whole lot of issues around skills. There are very few blockchain development skills in the world. And there's a cost-benefit conundrum, because even though you're kind of cutting out the middleman, in many cases, there still are transaction costs often that you have to cover. Opportunities in South Africa, I think there's some really good quick win opportunities, potentially around supply chain management and provenance, ensuring regulatory compliance, so certification of all kinds, and also combating counterfeit goods and fraud. And that's it. Thank you.